So, yeah, open the page where you've got the electron configuration diagram worksheet, please. So over 2 pages, I asked you to glue that paper in. So it should look something like that in the middle of the paper, yeah? Now, around here, I would like you to draw trends into it, okay? So a whole heap of arrows will go in, and we'll use the word increase or decrease, those trends that we look at, okay? Yep. Okay, lend you one. Good. Okay, so trends are something that you can observe over a period or within the group. It can be reactivity, atomic radius, other physical properties. And trends can occur across and also down. Yeah? So if you go, firstly, across a period for maybe around here, stop around there, we can look at how reactivity changes for the metals. Feel free to use different colors. So reactivity for metals, let's go with that. Now, the easiest one actually was reactivity that's going down, yeah? Because we watched the video a few times. So reactivity of metals. So reactivity of metals, as you go down, how does it change again? Yes, more reactive, so it would increase. Good. Yeah, it's more of the revision now. That wasn't really new. If you go to the right, what happens again? So if you go across, so looking at, say, lithium, beryllium to aluminum, what happens again, reactivity-wise? Think of which group was being the most reactive. Yep, so, yeah, because group 1 is the most reactive, yeah? As you go to the right, it should decrease, yeah? That's good. So reactivity of metals. I really need red. Decreases. I'll use different color. Okay, reactivity of metals decreases as you go to the right. Now let's just keep looking at the reactivity, but for right-hand side of that dotted line there. Reactivity of metals decreases. Now, I will draw another dotted line before group 18. Because if you remember, group 18 is noble gas. They've got full electron. They don't want to lose, don't want to gain. So they're very, very stable. So there is no reactivity. Okay? There's no reactivity for group 8 or group 18. But we can still talk about reactivity for these guys, other nonmetals. How does it change again? Reactivity of nonmetals, if you go from left to right. Nonmetals. Would it increase or decrease? Yeah, okay. Increase is correct. It just react in a different way or opposite way compared to metals. So it would increase. Okay. and I'm ignoring the group 18. That's for reactivity. Okay. Now, whereas for atomic radius, you can just look at the whole row, whole period. Right? Now, I would be putting this above as well, but because probably I can't reach well, I'll do it here. Atomic radius. So if you go to the right, what's going to happen again? So atomic radius changes over for the whole period, right? How does it change again? Now, because you're adding more and more proton as you go to the right, so the positiveness in the middle is getting bigger and bigger. Who is a popular band among you guys like nowadays? A couple of years ago, I used like One Direction as a, example, and so people still like it. That's good. I was like, no, they're too old. Like, don't use that anymore. Okay, I can use One Direction then. So imagine there was one member of One Direction just appeared in front of you, right? Maybe a few girls would notice, and some people are going like that. But compare that to the whole group of One Direction being there. How many more girls or how many more fans would be just getting crowded around? Okay, do you see the analogy there? If there was just fewer number of protons, the attraction that they have towards the electrons is a bit less. Okay, space between nucleus and electrons can change because it's mainly empty space. Okay. If there are more protons in the middle, just like having a whole group of One Direction, they would be able to attract electrons more. So as you go to the right, you're adding another member of One Direction or proton. The circle will become smaller and smaller. Does that make sense? Yeah, does that make sense? Are you getting the analogy here? Yeah. Good. So atomic radius, as you go to the right, how does it change? Increase or decrease? Atomic radius is the size of the radius would decrease. Okay, decrease is good. Okay, so if you look at all the elements in one row, say look at lithium to neon, which one is the smallest? In period 2, which one would be the smallest? In period 2, lithium up to neon, which one is the smallest? Neon it is. Okay. Lithium only has 3 protons, whereas neon on the right hand side has 10. More positiveness means more tightly packed atom. Okay. All right. What else was there? Oh no, that's for across a period. Let's look down a group. What happens again, or what do you see on your diagram? As you go down, what are you adding? What are you adding when you look at this diagram here? Hydrogen have 1 shell. Lithium has 2 shells. Yeah. Yes, you are. And that should correspond to period number, yeah? So 1, 2, 3, 4. So naturally, what's going to happen to the size, atomic radius? As you go down, increases. And that's visually you can see there, right? So atomic radius you keep using blue, increases. Following so far? So we looked at reactivity and atomic radius. Now, it's a bit hard to talk about physical properties in here, so I'll just skip that. Reactivity of metals and atomic radius. And reactive metal, reactivity of nonmetals. reactivity of nonmetals. That's something we didn't talk about. Okay. All right, atomic radius of, sorry, not atomic radius. Yeah, reactivity of nonmetals. Let's look at that. Maybe on this side, because you can find nonmetals on this side, yeah? What happens, you reckon, to say group 7 metals here? So fluorine, chlorine, bromine, and so on. Reactivity of nonmetals. Think opposite of metal, sorry? Well, wouldn't stay the same. It will actually, yeah, there will be a trend and it will change. Hint here, so reactivity of metals increase. For non-metals, think opposite. Yeah. So reactivity of metals, as you go down, it would decrease. Green I was using, decreases. Now let's think of why, once you've written that. Let's think about metal ones, because we should be able to visualize that better. All right, so metals, we said reactivity of metals increase as you go down, yeah? Why was that? You can use these words like atomic radius increases. So I would go, reactivity of metals increase as you go down the group because atomic radius increases. Meaning what? Meaning what? Yeah? Yeah. Atoms are becoming bigger, which is also changing distance between, right? Remember Jerus being a sodium atom? Now, remember electron had to come off from the outermost shell, right? It's usually held by the nucleus, okay? Because nucleus is positive, right? There's positiveness and negativeness, yeah? They're held together fairly closely. I might go back to the metaphor of, what do you call? One Direction again. If there was no barricade in between the One Direction and the U as a fan, right? Yeah, you might be very excited and you might be able to stay there for a long time, right? But if there were many, many barricades and security guards in between, you might feel distant. You might not be as attracted to the One Direction members. I don't know. I'm just saying that. It's just a metaphor. So if there were more layers of electron shells, and if you are the outermost shell electrons, you might not be as tightly held to the nucleus as the ones with shorter distance. Does that make sense? Does that make sense? Jerus used the magnet example as well. If I were S pole, and if Jerus was N pole, I have certain magnetic field, and I might be able to pull Jerus fairly well, okay? But Charlotte, if you are N and I'm S, I can still attract you, but because we are so far, you might go off really easily, right? So me and Jerus say we are like sodium, okay? Jerus can go off very easily still, but not as readily as say cesium. Okay, sodium to cesium, they're in the same group. Cesium is more reactive because I, as a nucleus, don't have hold. Does that make sense? So as the atomic radius increases, what happens? In your own words, can someone summarize that? As the atomic radius increases, what happens? For metals, we are saying it's increasing. Yeah. We can even add that, can we? So reactivity of metal increases because atomic radius increase, which means what Rebecca was saying, attraction decreases. Yeah, attraction between nucleus and electron decreases. We can add that there. PW between nucleus and E minus electron. So attraction between nucleus and electron decreases. And if attraction is very weak, electrons can come off really easily. Yeah, that means it's more reactive. So if you are asked to write a paragraph with 3 marks on it, I'm expecting you to be able to say, hang on, reactivity of metals increase as you go down because atomic radius increases and attraction between nucleus and electrons decreases. Did I answer your question there? Yeah. Okay, good. Sorry about messy writing there. And it's sideways too. It's worse. Bless you.
It's not coming.
In advance. All right. For non-metals, it's just an opposite of it. Okay. Non-metals, it's just opposite of metals. All right. Reactivity of non-metals increases because atomic radius still increases because you're going down. Atomic radius increases, meaning attraction between nucleus and electron decreases, so they can't pull another electron in. Non-metals, like Kate was acting as chlorine the other day. Yeah, remember, Kate was the one who was accepting electron. Okay, non-metals want electron instead. You see why? Because if you look at group 6 or 7, group 6 has got how many electrons in the outermost shell? Look at your diagram that you drew. How many electrons are in group 6 elements? 6, yeah. That's only 2 steps away from being 8, yeah? How about group 7? 7, and it only needs to gain 1 electron to become full, yeah? Is that connecting to you? If not, well, I'll ask you to write some paragraphs until it makes sense. Because I can assure you that there will be some explanation question. And we're already doing revision for the test, okay? By you writing this and by you writing, say, 3-sentence paragraph, okay? Let's practice doing this. Morning. So on this slide and slide before, there are a few things written there. So reactivity of metals increase or decrease, and why? Reactivity of non-metals increase or decrease, it should say, and why? When you go down a group, atomic radius of metals increase or decrease, and why? It says over again. Atomic radius of non-metals increase or decrease, and why? Second last slide. Reactivity of metals increase or decrease, and why? Reactivity of non-metals increase or decrease as you go from left to right, and why, and so on. Now, there are 8 patterns of question that I could be asking you, okay, in the test. Again, practice writing a paragraph using this information, okay. And last slide of the PowerPoint has got all the things that you can do for now. Okay. So start doing paragraphs. Try writing paragraphs to give explanation for the trends that you can find. And then start doing these chapter reviews. You got how many minutes? You got 15 minutes. All right. revision starts now. All right.